Uh, hey everybody, this is Larry. This is day 25 of the November Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. The smallest integer divisible by k. Okay, so given number k, find the length of the smallest positive integer n such that n is what? And I have to look at an example. These are terrible examples. Okay, so this is actually I mean, I know how to do this. I'm just trying to think about a way to explain it. There are a couple of ways you can think about it, all of them kind of weird. But basically, the idea is there are a couple. So I'm gonna go over the way which is more mathematical, and then we'll talk about it later in terms of finite state automators and stuff like that, FSAs. Okay, so basically the idea is that, okay, what does it mean when a number n is divisible by k, right? Well, a number n is divisible by k if the last digit of that number is 0 in base k, right? And what do I mean by that? What I mean is that, okay, if let's say you have a base 10, right? Well, in base 10, what numbers are divisible by 10? Okay, I mean, I think that's pretty clear. Any number that has a 0 at the last digit, that's divisible by 10, right? So you could kind of, and in binary, well, what numbers are divisible by 2 in binary, right? Well, all those numbers will have a 0 at the end because you could think about it as another way to think about it may be that if a number is divisible by k, then n is equal to k times another number, right? And in base k, that always shifts that number by that digit k by one digit, and it always adds the zeros at the end. So that's basically the idea behind here for the math part, and from that you could just do a for loop where. And there's a case, we'll go over why, there's a -1, for example, in a bit. But for now, we'll go over that part where, so the general pseudocode that I would write, except for it's in Python, so it'll be real code, is that, what am I doing? Changing length of the k? Okay. So for length in range sub, maybe just while true, right? While true, length +1. So now I'm going to write this in a naive way. It's not going to be right. So don't copy this at home. I mean, you could copy at home, but it's not going to be work. So we start with the number 1. This is the naive way to think about it. Is current. So you multiply it by 10. You add 1 to it. So that this is literally just shifting it and then +1, and then if current mod k is equal to 0, you return the length. Otherwise, this, right? So first of all, this is not going to be -1. This is -1. It may work in Python just because Python has ridiculous big nums, but it's probably too slow, right? So, oh man. So the first. I'm getting messaged right now, but so the thing that I would notice is me trying to turn off the sound off, but the first thing that I would notice just looking at this is optimizing this part, right? Well, you have this statement that you want to show, and current mod k is 0, right? But that means that you can actually mod k every step of the way, because the invariant in this loop is that the two things to notice about modding k. I don't know how to turn this off. I already quit this. Why? There's no way to mute this. Stop messaging me. You didn't message me for like a long time, and then but sorry, I'm getting messages. But okay, now that I turned that off, hopefully. But yeah, so basically now there are two formulas that you need to know, which is that, okay, current mod k, a plus b mod k is equal to a mod k plus b mod k, right? And then the second one is a times b mod k is equal to a times a mod k times b mod k, right? So from these things, those two things is enough to solve this problem, because now all you have to do is just add this, and then that should be good enough for the most part. And the way that you would think about it is, okay, how do you do the -1? Well, there's a -1 if this things repeat, right? And what does that mean? Okay, so this is where the FSA portion kind of gets started a little bit. And let me bring up my drawing thing. Hang on, I'm going to do some drawing for this one. Okay, so let's do some drawing, right? So let's say, we have a k here. Oops, that's a. So let's say we have k boxes, and that's how we're going to talk about it. Is that okay? So you have k boxes. Oh my god, I have to draw this. This is very okay. ... Right? So you can think about it as, a deterministic an input always gives you an output, right? As a function. And I think I have to re-record some part of this, maybe. Okay, maybe I don't want to draw it. I think okay, so I think the thing that I would say is that, okay, so let's say we have define a function f of x is equal to 2 x mod k times 10 plus 1 mod k, something like this, right? Which is what we implement here. So what does this mean, right? This is the function. This means that for the function f of x, and if we iterate it, there are k possible inputs to this function, right? And given that there are k possible inputs to this function, there are at most k possible outputs to this function, right? And the thing to notice about that then is also, well, what does that mean? That means that because this formula doesn't change, the same thing that you put in, you'll always get the same thing, right? And what that means is that if A goes to B, B goes to C, C goes to D, and so forth, eventually, if you see a cycle, that means it's always going to keep on going forever. And that's the only observation left to see. And from that, it is enough to go, well, to just add a set to this. Oops. S is scene is equal to set. And that's pretty much it. Otherwise, we add this to the set. And here, if current is in scene, then we return -1 because we've already reached this place, right? So that's pretty much the entire problem. And oh, whoops, I forgot to assign length. And why I bring up the FSA is because if you really draw these state diagrams of going from, and we'll go over it in a second. Maybe I'm off by 1. That's fine, because then that's easier to fix. Yeah, I didn't realize that there's so many thingies, but there's so many -1s. Also, I'm off by maybe 2 even. That can't be right? Oh, okay. I mean, I'm off by 1 because this is already 1, so yeah, because this is already true, so this should return 0. Oh no, this should be, they call it 1? Okay, fine. So maybe you start at 1. Yeah. And then now it's off by 1 because this should have, so, because we start at 1. And then, okay. Actually, no. I think this needs to be here. And then we do it. Okay, and stop hacking, Larry. Okay, there we go. Oh, did I? Wow, what am I doing? I have a lot of off by 1 issues, even though I got the algorithm right. Oh, because we don't add 1 to scene. Okay, there we go. Maybe now. Well, this is awkward. Oh yeah, this should be 0 to start with. Wait, should it? I'm trying to get my base cases right, but I think I've skipped forward a little bit. So this is 0. Oh. That's why. Oh, okay. Okay, and then now we could start at 1 because they count the first one as 1. I'm being a little bit silly here. That's what happens when you speed up a little bit too much. But yeah, so let's give it a quick submit. Yeah, so the question is, what is the complexity of this, right? And also, just to go back to finite state automata, the thing is that for each of these states, like I said, you could think about it as having k states. And if you don't know what I'm talking about, that's okay, because you should, I mean, for this to make sense, you have to have some understanding of what a finite state automata is. Definitely recommend learning that up. It is fundamental to a lot of stuff, but yeah, you could look at it as a graph where, you know, the input has an edge from input to output, and there may be a cycle or multiple cycles, and they deterministically an input goes to an output, and yeah, and that's pretty much the idea behind it. So let's go over the complexity of this problem, right? So what is the complexity? So the complexity is actually O of k, because as we talked about, this can only have at most k possible inputs. So this can only go, this loop, even though it looks like it could go on forever, can only execute at most k times. And because in that case, scene can at most have k elements, roughly less. But then in that case, it will take O of k space. So this is an O of k space called O of k memory, O of k time and O of k memory algorithm. Yeah, cool. And since k is less than 10 to the 5th, it should be fast enough. And because we do the mod, it makes everything a lot quicker. So we don't worry about complexity. Each of this loop is O of 1, so roughly. So that should be good enough. That's all I have for this problem. I am going to try to practice kind of explaining this in a better way for next time, but let me know if you have any questions. Let me know what you think. Hit the like button, subscribe button, join me this one, and I will see y'all tomorrow. Bye bye.